Welcome to the Demonstrating Implementation Excellence stream of SNOMED CT Expo 2023. My name is Farzan Ashrafi and I'm the Senior Terminologist at SNOMED International. I will be moderating today's session. For this specific session, Sookyung unfortunately cannot join us, so there's not going to be a QA at the very end of the presentation, but I'm sure that if you access the presentation, you can find the contact info and you can ask your question directly from him. I am now pleased to introduce Sookyung Huh from Severance Hospital, who will be presenting fine-tuning and developing semantic similarity model for mapping SNOMED CT to Korean clinical terms. Sookyung, please proceed.
Okay, thank you very much for the introduction. Hello, my name is Sookyung Huh, and I currently work as Health Information Manager at Severance Hospital in South Korea. And last year, I presented a model that mapped examination terminologies used in our hospital to SNOMED CT using a fine-tuned BERT. And this year, I am introducing a new model that incorporates further pre-training and fine-tuning. And additionally, we've integrated a traditional keyword matching algorithm to enhance the quality of SNOMED CT mapping. So in today's presentation, I will explain the new model and compare it to the last year's model's results. So for a brief background on our SNOMED CT mapping project, so in August 2020, South Korea became the 39th member of SNOMED International, with the expectation of standardizing medical terms to promote various medical research and healthcare services. So since then, numerous projects have been initiated to promote the implementation of SNOMED CT. Some examples include the certification of EMR, which recommends SNOMED CT as the terminology standard. Another is the data-driven hospital project, driven by the government to promote the usage of medical data. And one of its tasks is terminology standardization. So such projects have encouraged medical institutions in South Korea to map their local terminologies to SNOMED CT. So examining the current status of medical institutions in South Korea, around 60% of the diagnosis terminology is mapped to SNOMED CT, and about 53% of the operation terminology is similarly mapped. However, the mapping rate for the other terminologies, such as examinations, nursing, etc., is significantly lower. So to assist in the mapping process, the Korean Health Information Center has released various SNOMED CT maps in collaboration with researchers. So these include the Korean Standard Classification of Diseases, which is the Korean version of ICD-10, and Electronic Data Interchange Code for SNOMED CT, which pertains to the insurance code for procedures and medical behaviors. So these types of SNOMED CT maps certainly facilitate more accurate mapping and reduce the time and effort required for the process. Severance Hospital is one of the largest hospitals in South Korea, and from the inception of our EMR system, we have emphasized the standardization of medical terminology. Our EMR system was launched in 2005, and within this system, we also established a clinical terminology master dataset. And we have a committee dedicated to terminology standardization, which includes subcommittees for data standardization, data quality, and the common data model committee. The primary goal of this committee is to establish standards for terminology and clinical record management. And they handle matters related to mapping and criteria for the terminology classification systems. So we hold quarterly meetings to discuss the current status and our standardization efforts and address any challenges or issues related to this initiative. So since the inception of our EMR system, Severance Hospital has been mapping SNOMED CT and managing the map of diagnosis, surgery terminology. And due to the government's data-driven hospital projects and research on CVM and other clinical research, we are progressing in the standardization of various clinical terminologies within the hospital. And starting last year, we began mapping examination terminologies and utilized a fine-tuned BERT model to assist in the mapping process. And standardizing examination terminologies is very crucial, especially for significant examinations like imaging and pathology, as these can be very variable for research on standardized. And examination terms are often mixed of both Korean and English. It can be complicating the search for the appropriate SNOMED terminology. And additionally, many medical abbreviations are used in examination codes, necessitating data cleaning before the mapping. So while some examination terminologies are mapped with the EDI code, the EDI SNOMED, EDI, sorry. EDI SNOMED map facilitates only 30% of the mappings, and these limitations makes the mapping process both challenging and very time-consuming. So to outline the mapping challenges, mapping Severance Hospital's examination terminology to SNOMED CTs quite difficult because the terminology is consistent with Korean and English terms. It needs translation before mapping. And as a result, the mapping process can be time consuming and it requires experts' input. So to address this challenge, we employed a natural language process model for SNOMED mapping. And this model uses an algorithm capable of semantic interpretation. And essentially, our aim was to automate the SNOMED CT mapping through NLP. So this was the overall workflow for our previous model. First, we pre-processed the examination terminology data. And after this pre-processing stage, we prepared 3 sets of input data along with the training data set and making them ready for the model training. And once the model was trained, we evaluated its performance and conducted validation on the resulting output. So this was a basic approach where we fine-tuned deeper model and specifically for our semantic similarity matching task. So we trained the various BERT model to select the best one, and we utilized BERT that was trained on a large-scale biomedical corpora and then fine-tuned it using the SNOMED description and examination terminology from Severance Hospital. So to achieve better performance, we segmented the training based on the examination code groups. So even though the model greatly assisted in the process of mapping examination terminologies, there were some challenges. So the first would be the lack of domain-specific accuracy. So the fine-tuned model was not sufficiently accurate in mapping specific domains of examination terminology, especially in areas such as pathology or radiology. And we believe this was due to the abundance of abbreviation within those particular examination terminologies and the absence of corresponding mapped terms in SNOMED CT. And there were the problems of underperformance on infrequent terminologies. So the model struggled with some infrequent or less common medical terminology. And also there was limited knowledge scope. The initial model's knowledge was confined to the map data, meaning it didn't have a comprehensive understanding of the broader SNOMED CT terminologies. So given that SNOMED CT comprises of almost 506,000 concepts descriptions, and it was a significant challenge to map, and train the model on all these terms during the fine-tuning phase. So the model's knowledge was primarily based on the map data, which might not have covered all the nuances and intricacies of medical terminologies, leading to the potential gaps in understanding. So this is the overall pipeline for the improved model. So first, we continued pre-training BERT using unsupervised text data such as SNOMED CT procedure descriptions, examination terminologies used in the hospital, abbreviation, and so on. So in the second step, we fine-tuned the pre-trained model using supervised data, which consists of examination terminologies mapped to SNOMED CT. And third, we embedded the examination terms in SNOMED CT descriptions using the fine-tuned model. So we then matched the top 5 most closely related SNOMED CT terms. And finally, using a keyword matching algorithm, we identify the best term. To briefly explain the examination terminology data from Severance Hospital, the terminology is classified based on the examination code group. So it's sorted according to the field of examination and the department conducting the examination. So we reorganized some of these classification and created 8 groups for training. So here are some examples of the examination terminologies. So the terminology database itself contains a wealth of other metadata with around 80 different types. So this includes data such as insurance type, examination department, and so on. So this metadata was also utilized in the training the model. So since the radiology section didn't perform well with the previous model, we only focused on training with radiology terminology. So the first step is the continued pre-training phase. During this phase, we aim to achieve 3 main objectives. First, domain adaptation, second, knowledge augmentation, and lastly, bridging the gap. So imagine a general diagnostic tool trained on a broader spectrum of disease. And now we suppose we want this tool to specialize in cardiology. And the domain adaptation is the process of refining this tool to excel in cardiological data and scenarios. So in the context of machine learning, it means adapting a general model to cater to specific data, enhancing its proficiency for tasks within our medical domain. So knowledge augmentation focuses on deepening our model's understanding. So we achieve this by introducing it to more specialized medical data and terminologies, so addressing the gaps or the nuances that might have been overlooked during its primary training. And lastly, bridging the gap, it ensures a seamless transition for our model from its foundational knowledge to its specialized expertise. So this step is very pivotal because it's guaranteeing that our model delivers peak performance when tasked with specific medical challenges. So for continued pre-training, we utilized SNOMED CT procedure description, examination terminologies used in our hospital, and abbreviation terminologies, and more. So by continuously training on these texts, the model not only gains knowledge of SNOMED CT description, but also becomes attuned to the nuances of the terms specific to our hospital. So after the continued pre-training phase, we proceed to fine-tune the model using the data from the phase. So this step is very crucial to leverage the knowledge gained during the pre-training while tailoring the model to a specific task. So for our supervised data set, we use examination terminologies that have been mapped to some SCT descriptions. And each mapping came with a labeled score, so indicating the degree of similarity between the terminology and its corresponding some SCT description. So for fine-tuning phase, we use labeled examination data to SNOMED CT. So regarding the labeling process, first we map the examination code using the EDI SNOMED map, and then we confirm the mapping. And secondly, we map the remaining terminologies and label the map with scores ranging from 0 to 5 based on the type of mapping. And a score of 0 indicates no similarity, and while score of 5 represents an exact match. So we assign the highest score of 5 to the most precise mapping, and for rather or partial mapping, we reduce the score accordingly. And BERT is a transformer-based machine learning technique for natural language processing pre-training developed by Google. And additionally, we employed sentence transformer, a Python framework for sentence embedding. And it can be used for classification tasks or to compute similarity scores. So delve into some detail, we train on pairs of sentences that are annotated together with a score indicating their similarity. So the scores range from 0 to 5, and we normalize these scores by dividing by 5. So given the cosine similarity ranges from -1 to 1, once the sentences are embedded by the BERT, they pass through a pooling layer, and this layer uses mean aggregation to generate vector u and v. And cosine similarities are then computed between u and v, and we compare this computed similarity with the provided label to train the model. So in the final stages of our process, we utilize two main data sets, the examination terminology from our hospital and procedure descriptions from SNOMED CT. And both data sets were embedded using our fine-tuned model to determine their semantic similarities. And our specialized algorithm then analyzed the embeddings to identify the top 5 SNOMED CT description that best aligned with each examination term. And to further refine and ensure the accuracy of these matches, we implemented a keyword matching algorithm. So this method compared keywords pinpointing the most accurate SNOMED CT description for each examination terms. So this is the result of the best matched terminologies. For radiology segment, the model achieved an accuracy of 72%. It's an improvement from the previous model's 65%. So compared to the previous model, the improved model exhibits 4 primary strengths. The first is domain adaptation. The model has become more attuned to the medical language, resulting in enhanced performance in understanding and generating medical terms. And second, it could handle translation. So by incorporating translation of Korean terminology into English, the model is now equipped to understand and correlate terms across the language. So this capability is very vital for international collaborations and referencing global medical literature. So for example, when the term ultrasonography in the first trimester is translated from Korean and pre-trained, and the model can seamlessly relate it to its English counterpart and its contextual relevance in medical procedures. And it can understand the abbreviation. The enhanced model is now proficient in recognizing some of the mapping medical abbreviation terms like L spine, which is lumbar spine, C spine, which is cervical spine. These are accurately identified and associated with their respective SNOMED CT description. So this advancement underscores the model's refined training on an extensive sets of abbreviation, ensuring more precise mapping in clinical scenarios. So also, there was an enhanced accuracy The updated model demonstrates a improvement in its ability to distinguish between terminologies. Previously, multiple distinct terms were sometimes mapped to a single SNOMED CT. And with the advancement in our model, such incidents have been reduced, leading to precise and individualized mappings for each terms. So SNOMED CT plays a very pivotal role in standardizing clinical terminologies across the globe. Building upon our previous work, we've made advancements in our model, leveraging the richness of SNOMED CT descriptions and its inherent structure. And these are the feedback potential to SNOMED CT. First, synonym learning from SNOMED CT descriptions. So utilizing SNOMED CT descriptions and the same concept description terminologies within SNOMED CT has been very variable. So by treating this as synonyms, our model gains a deeper understanding of the domain, leading to more accurate mapping. So this approach can be adopted in other SNOMED CT applications, ensuring that synonymous terms within the ontology are effectively recognized and utilized. And second, abbreviation understanding. So incorporating abbreviation has significantly enhanced our model's performance. So by recognizing and understanding common medical abbreviation, the model can now match terms with some more accuracy. So emphasizing the inclusion and the standardization of abbreviation within SNOMED CT can further enhance its applicability, especially in environments where abbreviations are frequently used. And third, fine-tuning with medical terminology mapped to SNOMED CT. Fine-tuning our model using hospitals' medical terminology that's directly mapped to SNOMED CT improves its performance. So this approach ensures that the model is aligned with standardized terminologies of SNOMED CT, leading to more accurate and consistent mappings. Encouraging the use of direct mappings in training models can ensure that other applications also benefit from the standardized structure and terminology of SNOMED CT. And lastly, using keyword matching algorithm. Our approach of counting keyword matches within the vocabulary and weighting the results based on the number of matches has positive impact on the model's performance. So this ensures that the most relevant and comprehensive terms are selected. And implementing a similar keyword weighting mechanism with SNOMED CT search and matching algorithm can improve the precision of term retrieval. So our improved model stands as a testament to the versatility and depth of SNOMED CT. So by focusing on description, abbreviation, direct mapping, and enhanced keyword matching, we've achieved better results in terms. But there are also limitations. The first is accuracy is not absolute. So while our model has shown significant improvements over the previous iteration, it is essential to note that the accuracy is still not 100%. So there are instances where the model might not map terms correctly, especially with nuanced or highly specialized terms. And also, there are the quality training data. So as with the previous model, the quality of training data remains very paramount. The translation of Korean clinical terms into English is still a challenge, especially since SNOMED CT does not provide Korean descriptions, and expert effort and time are very crucial to ensure the quality of mapping data. And mapping the infrequent terms. So the model, despite its advancement, it sometimes finds it challenging to map some infrequent terms accurately. So to address this, augmentation process was implemented to artificially enhance the representation of these infrequent terms during the training. However, the challenge persists and further refinement of documentation process is needed. And for the validation process remains essential to ascertain that the correctness of the mappings. While we've made strides in automating the mapping process, a manual validation by experts is indispensable. And for the future plans, we are planning to explore other NLP techniques. And while our current model has shown promise, we remain open to evaluating other natural language processing techniques that might offer better performance. So the field of NLP is rapidly evolving, and staying updated with the latest advancements is very crucial for the continual improvement of our model. So this was my presentation, and if there is a question, or I can answer them. Thank you very much for your attention.
Thank you.
Thank you.
So Sookyung is not able to join us live for Q&A, so I will now ask her a few questions. The first question that I have is, what specific advantages have you observed by incorporating continued pre-training before fine-tuning?
So the incorporating the continued pre-training before fine-tuning has provided several advantages. First, it allowed the domain adaptation, making the model more attuned to the medical language and enhancing its performance in understanding. And secondly, it facilitated knowledge augmentation. So it deepened the model's understanding by introducing it to more specialized medical data and terminologies. So, and this addresses gaps or nuances that might have been overlooked during its primary training. So these are some of the advantages of pre-training.
Thank you. There is another question. Could you elaborate on the keyword matching algorithm's role and its impact on improving the mapping accuracy, please?
The keyword matching algorithm, it enhances the model's output by ensuring that the chosen SNOMED CT descriptions are not just semantically similar, but also contextually and lexically appropriate. So this dual layer approach significantly improves the overall accuracy of the mapping process.
Understood. And finally, what further improvements or adaptations do you see for your model in the upcoming years?
So in the upcoming years, we plan to explore other natural language processing techniques like GPT. So we plan to explore the capabilities of models like GPT for the mapping process. So GPT is a transformer architecture, and its ability to understand context can be pivotal in improving the accuracy of the term mapping. So these are some of our plans.
Thank you so much. With that, we will conclude this session. Thank you, Sookyung, for the great presentation.
Thank you very much.